Okay, good morning, all you fair weather people that don't come to school. Good to have you with us. We have a few students here in the class, but we're going to try to not let them talk at all. But anyway, we are going to go to page 8 in your workbook, so you can go there, and we're going to talk about square roots. So the first lesson, we already talked about that last chapter with rational numbers and what's rational and integer and whole. So we're going straight to square roots. This is going to be a lot of review for you. It says when a number is multiplied by itself, the number is squared. For example, 3 times 3 is 3 squared. So that little power up there, I think you've seen that before. Have you seen that little 2 up there? It means 3 by 3. Don't ever be confused. That does not mean 3 times 2. That's the most common mistake that's made. That is not 6. 3 squared is 3 times 3, which is 9. This section focuses on which number needs to be squared in order to produce a given number. The process of undoing or reversing the square process. Read again, the process of undoing it or reversing the square process is to find the original number used in squaring is called finding the square root. So if you can write down here on your paper, write these notes. Square, so we're going to say squaring is the opposite of square root. And they are not to be confused. Some kids say the other thing and they go, oh, well, same thing. No, it isn't. It's completely opposite. Adding is not the same as subtracting. Squaring is not the same as square rooting. They're actually opposites of each other. Okay, so use the correct words so that then you use the correct buttons on your calculator, whatever. So this little sign here, this little, I don't know, call it for divide with a little hoop thing on it, is called the radical sign, and it is used to indicate the square root of a number. Okay, so these perfect squares. Now I have drilled you a little bit on what perfect squares are. So if you all remember, I could say, what's 15 squared? And you would say it louder. Anna's got it. 225. 15 squared is 225. So you need to know all this list. By the way, those were all right here for you. If you were freaking out if I was going to ask you. They're all there. You need to know them. 1, 2, 3, right? 1 squared, 2 squared, 3 squared. You need to know those pretty much. You do not probably need to know this group of numbers. I don't know those group of numbers. But everything else on that list, like I don't know what 21 squared is, but I pretty much can figure out all the rest of them, and 25 squared is a very common number, 625. Okay? You need to know those. Go home, get a game on the computer, get your mom to quiz you on those so that you know what those perfect squares are. Okay? So, 14 squared? No calculators allowed. This whole lesson, there's no calculators. Like, throw your calculators away. Brooke, 14 squared, 196. That's right. You got to know all those numbers. Okay, so those are called perfect squares. The reason they're called perfect squares is because of this. If you make a square, wow, it's a crazy square. If you make a square and you want to talk about the side lengths of it, if this is 11 and this 11, like if one is 11, they both have to be 11, right? To be a square. And guess what this number inside is? 121. So we call 121 a perfect square because it is the area of a square with side length of 11. Does that make sense? So if I draw another square up here and I say this is 7, then this has to be 7. And so this area is 49. Therefore, 49 is called a perfect square because there are two numbers, 7 by 7, would create a square. You with me? All right, that's why they're called perfect squares. So this should be a lot of it should be reviewed. Okay, so here it just says it again. Example 1, a square has an area of 9 square units. What must the length of each side be? And you know it's 3. That's right. If there are 9 units in there, then each has to be 3. So we can then say the square root of 9 is 3, or a 3 by 3 will give us a perfect square of 9. Whichever way you want to go. Okay, so in example 2, it says determine the exact square root if possible. I know that you have answers and solutions down below. I kind of would like you to forget that you have those and just write on along here what they are. What's the square root of 25? What's the square root? What is the negative square root of 16? Say it louder, Brooke. Negative 4. So this negative here doesn't mean, you just write it down. It's a negative sign. And then you say, what is the square root of 16? And we get 4. Very important. Because what is the square root of negative 4? When it's all inside the radical sign. Now you got to go, oh, square root. Okay, well, the square root of 25 up here was 5 because 5 times 5 was 25. True? Well, what would this be? What's the square root to negative 4? What two numbers times themselves will give you negative 4? Anybody? Go ahead. Okay, so 2 times 2 is what you think of, but that gives you a positive 4, not a negative 4. So what else could you try? Oh, negative 2 times negative 2. What is a negative 2 times a negative 2? Positive 4. So there is nothing. People, there is nothing. Right? Nothing there. There is nothing that you can multiply by itself that will ever give you a negative number. Because a negative times a negative is a positive, and a positive times a positive is a negative. Are you with me? They have to be the same. You have to have the same thing here and here, and nothing you do will ever give you a negative number. Okay, what's the square root of 0? 0. 0 is different than nothing. Okay? Be sure you know that. 0 is not the same thing as nothing. 0 is a number. It's actually a whole number. Nothing means it doesn't even exist at all. Okay? Nothing is not the same as 0. What is the square root of 4 9? Does anybody want to try? 2 over, 3. 2 over 3. Take the square root of 4, square root of 9, you get 2/3. Life is good. Square root of 2/18. Is there a square root of 2? That's nice. Like there is one, but it's irrational. Is there a square root of 18? Anything times itself give you 18? Nope, nothing. So you almost think, well, there isn't one that's rational. Well, but let's do a little, what could you do first? Could we simplify 2/18? Yeah, we could. So we could say, okay, well, we're just going to do this. 2/18 is really 1/9. So, yeah. Is there a square root of 1? Yes, it's 1. Is there a square root of 9? Oh. So at first glance, it appeared as though there was not going to be any nice rational number with the square root of 2/18. But if you simplify first, you can go on and find one. Good job. Okay, square root of 5. Is there any such thing? Like it's a rational number? No. So I'm just going to write, do you remember the symbol for irrational? It's a Q with a line over the top. It means irrational. Okay, how about the square root of 9 and 16? What should you do first? Anybody want to take a gander what you should do first there? How about we actually do those together first? Think of it as being under the bracket. So we're going to go the square root. 9 and 16 is 25. Is there a square root of 25? Yeah, 5. Good. We're good there. Okay, what about this one? What about I? Do you think it's going to be 5 when we're done? No. What's the square root of 9? 3. What's the square root of 16? 4. And the answer is 7. I want you to take a look at those two things right there. They are not the same thing. Okay, so right here, I want you to write up here. Square root of 9 plus 16 is not equal to the square root of 9 plus the square root of 16. We just proved it. Because this one, oh, that's a 16 out of 6. We just showed that 9 plus 16 is 25. This is going to be a 5 when we're said and done. And this one is going to be 7. Those are not equal to each other. Get it? Got it? Good? Understand? Okay. All right, how about this J? Here we are at J. The square root of 4 squared. Anybody want? What could you do? Square root of what? Could you actually find out what 4 squared is? What's 4 squared? 4 times 4 is 16, right? What's the square root of 16? Woo! Take note what happened. We had the square root of 4 squared, and we ended up with just 4. Do you know why? Because on the page before, you wrote down that squaring is the opposite of square rooting. Right? You wrote that down? So that means that the square root of 7 squared is going to be, right away, say it fast, 7. The square root of 8 squared is going to be 8. The square root of y squared is going to be, yeah, just y, just y. The squared and the square root, it's like they cancel each other. They're the opposite. It's like timesing and dividing by the same number. It's like nothing, right? You with me? So squaring and square rooting are opposites of each other, and we just proved it. The square root of 4 squared ends up just being 4. Okay? Jesse? Back right here. Okay, square root of 0.81. Square root of 0.81. Okay, what do you see when you see that? Square root of 81, right? Are you thinking 81? So what are you thinking? Like 9? So do you think it is like 0.9? 0.09? Oh, could you put it into a fraction? Good call. Let's do that. Square root of 8. Well, how would you put it in a fraction? It's 81 over 100. And now, can you see the square root of 81? Yes, you can. What's the square root of 81? 9. Square root of 10. Sorry. Square root of 100 is 10. So your answer is 9/10, which is the same as 0.9. So this is what you're going to do. It's a very good way to do it. If you have no calculator, which you're not going to have this entire chapter, you're going to do with no calculator, you're going to have to turn this in. If you can, now you might check, if you check this out, you might see. Do you know that when you go 0.9 times 0.9, I'll write down over here, 0.9 times 0.9, you know that you're going to get 81. Do you know how many, do you know where to put your decimal place? Do you remember that if there's however many numbers there are behind the decimal when you multiply, that's how many numbers that you have behind your decimal when you get your answer. So there's one decimal or one digit behind here and one digit behind here. That means I have to have 2 digits behind here. So that's where your decimal goes. That's a good reminder in case you didn't remember that. Okay, so however many digits are behind the decimal in your question here have to be, you add them together, there's 2. So there's got to be 2 behind the digit or the decimal when you put your answer down. Okay, all right, that's good remembering. A lot of good stuff there. Turn the page. And I'm done. So that means you're ready to roll, and you need to do all the questions in this 3 pages, and you're not allowed to use a calculator. So go to her. You'll have it done easy, I'm sure. And good luck for those of you listening on the other side of the screen. Okay, goodbye. Over and out. Somewhere. I don't know how to. Oh, crud. Oh, stink. I don't know how to turn you off. Oh, here it is. Okay.